This is going on page 25 when we're done, which is the same page as yesterday's. So I'll remind you of what to do when we get to the end if you're not sure how to make it all be together. But yesterday we talked about some extrema, right? For our polynomials, we're going to look at points of inflection today. We've already talked about points of inflection specifically, but not specifically with polynomials. I mean, it doesn't change what they are. But a point of inflection, it occurs when a function, any function, doesn't have to be a polynomial, changes from concave up to concave down, or vice versa, either way, okay? At a point of inflection, so that's what it is, this is where it is, at a point of inflection, the rate of change of a function changes from increasing to decreasing, or vice versa, okay? And so one of the things that we want to look at today, which I have seen a couple of people write on top of one of the quizzes, whichever one it was more appropriate for, is our fun chart, right? So we have our function, then we have, that's why it's called the fun chart, because it looks like fun, right? And then up, down. The original time we wrote it, we put slope right here, which it is slope, but we're going to put rate, ROC for rate of change. And then up, down, plus, minus. So up, down, up, down, up, down, up, down, plus, minus. Okay, so it's a pretty easy pattern to remember. One of those things that might be helpful to write on, depending on what you're doing, but it can help you wrap your mind around all of this. Okay, so let me ask you some questions here about this function. Or let's just talk about what's happening with this function. So I'm starting here. My function is decreasing, then my function is increasing, then my function is decreasing, then my function is increasing. Does that make sense? When I'm talking about my function increasing and decreasing, what part of the function am I talking about? Like, what about the function is increasing and decreasing? Not the rate of change. The function is decreasing because why? What is decreasing? What do I mean when the function is decreasing? What part of the function is decreasing? Because right here, the rate of change is actually increasing. The y values, exactly. So my function is decreasing. Actually, right here, my rate of change is increasing because my rate of change is negative, right? And it's pretty steep. So it's getting less and less steep, which means it's getting closer and closer to 0, then becoming positive. So my rate of change is actually increasing. My function is decreasing, okay? So not only is it decreasing, but since the rate of change is increasing, it is decreasing at an increasing rate. It's like stopping quickly, right? If you slam your foot on the brake, then you are decreasing your speed, but the rate at which you're doing it is increasing because you can stop quick. Does that make sense? Like instead of just taking your foot off the gas. All right. So then we also want to talk about, so you have to make sure you can wrap your mind around whether we're talking about the rate of change or the function, because those are two different things. And that chart right there can help you. All right? If you can figure out what the function is decreasing, the function is increasing, right? Can you figure out by looking if it's concave up or concave down? For the most part, right? So if I'm concave up, for right here, for sure, if I'm concave up, that means this whole part right here till somewhere, we'll discuss specifically where in just a second, but if it's concave up, then I know my rate of change is increasing. That's what this chart is telling me. Since my function is decreasing, that means my rate of change is negative. You with me on that? You can also use your pencil to know those things, but it goes along with the chart too. And sometimes having the chart help you kind of make sure everything is gelling together in your brain is very helpful. Okay? So we've talked about for our function increasing and decreasing, and our function being concave up and concave down. So let's talk about our function being positive and negative. So if I want to know if my function is positive and negative, where is my function positive? And what are we talking about being positive? If we're talking about the function, the y's. So the y's are all positive where? Above the x-axis, exactly. So my function is positive here and here. Okay? So we are talking about the y's. right? The y's are increasing, or the y's are decreasing, or the y's are positive, or the y's are negative. We're talking about y, but we are always writing about x. So my function starts to be positive where? What's the furthest to the left it becomes positive? Negative infinity. So it's negative, sorry, let me just write negative infinity here. What is the name of this function? Do we know? What does number 1 say? Or number 3, I guess. It says the graph of g of x. Notice how the graph isn't labeled, right? But we're going to label it g of x. Okay? So there's g of x. So then I can say g is positive on the interval, but I can leave off the words the interval. Just saying on is fine. We are starting at negative infinity, and it's positive until it gets to where? Negative about, we'll say 3.5, okay? Negative 3.5. All right, do I get to include 3.5 and why or why not? No. What is the function value when x is negative 3.5? 0. Is 0 positive? No. Is 0 negative? No. So we do not get to include it. And then I union that with, and I'm going to write into my function here, I start back over being positive at 3.5, and I go to infinity. Okay? Does that make sense? Remember I told you we are leaving everything open unless we're talking domain or range or some other specific things that may come up that we'll talk about. But increasing and decreasing is where there's that controversy and teachers can argue about what's right or wrong. If you close the interval on concavity incorrectly, or you close it on the positive and negative, you're 100% wrong. So I'm telling you, it's safer just to leave them all open and not overthink it. All right? So then we're going to talk about g being negative. G is negative on, well, it's negative here and here, right? So I know I can start at negative 3.5. Can I go all the way to 3.5? No. Where can I go to? 0. And why can't I include 0? Exactly, because not only is the x 0, but the y is 0 there as well. So then I have to start back over on the other side and go from 0 to 3.5. Okay. What questions do you have? We good so far? So this right here, total review. This is not in anybody's notes anywhere, but you're going to have questions about it, so you need to make sure you understand it. Okay. All right. Let's look at example 3. It says the graph of g of x is shown in the figure above. We've already labeled it. That's good. We're going to use the graph of g to answer the following. Find any values of x where g has a point of inflection. So a point of inflection occurs when a function changes from concave up or concave down. So that's right here in my little fun chart, right? This is my point of inflection. Now, we can use for note purposes and for if we're just kind of labeling stuff for ourselves, POI is fine. If I'm writing it out in an explanation, just like AROC is okay to write when we're just taking notes and stuff, if I'm using it in an explanation, I cannot write AROC. I have to write average rate of change. And if I'm using it for myself, POI is fine. But if I'm writing it out, I have to write point of inflection. I can maybe abbreviate some of the words, but I can't just put POI and make my own acronym. Okay? Does that make sense? All right, so that means that not only, and then it also says a point of inflection is when the rate of change changes from increasing to decreasing, which is in this same part of the table. That's what happens in between those. That's how you know where the point of inflection is. Graphically, we are estimating right now, okay? That's kind of the best you can do without the calculus behind it. So would you say, here's concave, so this is concave up, so probably right about there at -1. Does that look good for that one? Okay. And then we're concave down probably till right there. And then we are concave up again. Okay. Make sense? What is that noise? Y'all hear that? It's not just me. The voices in my head. It's not coming from in here, is it? It kind of sounds like it's coming from. Okay. I think it stopped. I don't know what it is. All right. Okay, so where is this then? What's my answer? X equals, is it you? Is it coming from out there? It's just bugging me what it. Kind of sounds like an alarm of some sort, but nobody seems concerned. It also sounds like a truck backing up, but I don't see a truck. Okay, we're just going to ignore it. Move on. All right, so X equals -1 and 1. Y'all agree with that? Okay. No, I can't stop hearing it. All right, any questions at this point? All right, so let's look at these. This says, for each of the following intervals, determine if the rate of change of G is increasing or decreasing. We're going to add some extra stuff to this. And positive, negative also. Oh, spell. Positive, negative also. And we have to explain. That's huge. Okay? So the first part we're going to look at is from 3 to 4. So I'm going to go back up here. And from 3 to 4, that's this part of the function right there. Okay? So, do you think it's easier from the graph to visualize and see what's true about the function or what's true about the rate of change? Which one's easier for you? My guess is the function, right? Is the rate of change where we're getting a little mixed up on these things? So this is the function increasing or decreasing here? Increasing. So if the function is increasing, what's true about the rate of change? It's positive. If the function's increasing, the rate of change is positive, right? And for this section right here, is the function concave up or concave down? Concave up, which means the rate of change is increasing, okay? Our question, what is our question asking us about? For each of the following intervals, determine if the rate of change of G is increasing, decreasing, or positive or negative. So again, make sure you're answering the question that's being asked. Don't answer the question about don't answer it about the function if it's asking you for the rate of change. So we decided that is the rate of change increasing or decreasing? Increasing. And is the rate of change positive or negative? Positive. So we can say the rate of change, or I'm just going to put rate of change. It's okay, leave the off. English teachers aren't grading this, so it's fine. Rate of change of G is increasing and positive on 3 to 4. Okay? So that is my answer. That is not my explanation. But in my answer, I talked about what rate of change of G, where on 3 to 4, and what my answer is, increasing and positive. Then I can say because, and because is fine with B/C. It's way shorter than because, and it's shorter than since. I mean, you can use other words and say it differently, but I think this is kind of the easiest. Okay, because, and we knew that because, how do we know that the rate of change is increasing? Because the function's concave up, right? How do we know it was positive? Because the function is increasing, right? So I have to use evidence from what I have here talking about, and I can't just say, well, because it's getting steeper or whatever like that. Yes, I can use my pencil to figure it out, but I can't say on my AP test that I use my pencil to figure it out. Like, that's not an explanation. So I can say rate of change of G is increasing and positive on 3 to 4 because G is concave up and what? Increasing on 3 to 4. So even after because, I have to have what? G, where? On 3 to 4, and what's happening. Okay? It's a who, what, and where type of thing. Everybody okay with that? What questions you got? Okay, so let's look at Roman numeral 2 here, -4 to -3. So -4 to -3 is right here. That part of the function, is that part of the function increasing or decreasing? Decreasing. Is that part of the function concave up or concave down? Concave up, which means that the rate of change of the function on that is what? Positive, and is it positive? Increasing, because there's concave up, which makes it increasing. Function is decreasing, which makes it negative. Okay, so it's increasing and negative, which means it's decreasing at an increasing rate, right? So here we go. We're going to say that the rate of change, now we're not going to do Roman numeral 3, so you can write into that a little bit if you need to. So we can say the rate of change of G is, was it increasing or decreasing? Increasing. And what? Positive or negative? Negative on -4 to -3, right? So that's my answer, not my explanation. Just because I wrote words doesn't mean I explained anything. Because G is concave what? Up, concave up, and what? Decreasing on -4 to -3. Any questions about that? Are we good? All right, so I'm going to give you a minute or two to discuss at your tables this fourth one. We're skipping number 3, look at number 4. And talk to each other. Okay, so I started your explanation for you. I hope I've given you enough time to write yours down, and here's what I want you to do. You need to be confident enough and brave enough to actually write something down before we discuss it as a whole. If yours isn't 100% correct, here's my suggestion where learning actually happens, because it's okay to be wrong. Unfortunately, as human beings, we learn from our mistakes more so than we learn from being right all the time. Instead of erasing it, if something is incorrect, mark it out, but not scribble it out where you can't read it. Just like put a couple lines through it and then write what the correct thing is, because there's some power in that. If you actually go back and look at your notes, if you're still confused about something, you can be like, well, that's what I thought it was, but it's really this, and now I understand why. You with me on that? So sometimes it's good to see your mistakes so you remember what it's not also. That can be helpful. Okay, so we've got rate of change of G. We're looking on 1 to 2 here. So from 1 to 2, let's see, let me find a different color here. 1 to 2, I'm going right here. Okay, so I'm going to pick somebody to give me the answer, and then also pick somebody to give me the explanation here. So let's see who my first lovely assistant will be. Christopher Wynn, where are you, hon? Okay, so tell me, rate of change of G is what? And negative on 1 to 2. All right, do we agree with that? Okay, so let's go up here and let's look. He's saying it's increasing and negative. So my rate of change, if we're looking at it with our pencil, right? My rate of change is negative, yes? And as I come along here, it stays negative, but it's getting closer to 0 till it gets here, and then it becomes positive, which totally means that it is increasing, right? It's getting bigger, and it's negative. Thank you very much, Christopher. Then we're going to have a because, and let's see who my second lovely assistant is. Sitlali. Because why? G is concave up. And what? Decreasing on 1 to 2. Okay, do y'all agree with that? Yes. So what I talked about when we were confirming Christopher's answer, I didn't say it for a couple reasons. I didn't want to give away the answer. This is what I need to be able to write. This is what I need to write, but we also kind of need to be, Shoot, I always move the wrong thing. We also need to be able to understand it both ways. Okay, we good? Any questions at all? All right, so we're going to skip example 4 until we get to using our calculators, then we'll come back and do it. It won't be too long before we actually start doing that. So flip it over. It says, can you determine how many points of inflection occur in the graph shown below? So let's talk about something else first. How many turning points do I have? 3, okay? So my turning points, so I'm decreasing, then I increase, then I decrease, then I increase, right? So I have 3 turning points, which is not even what it asks for, but that's okay. I like throwing in my own questions. 3 turning points, even though I put this together. I always think of it after I copy it. 3 turning points. What is the official way? Because turning points we started with yesterday, but then we learned some real words here. Our turning points are actually what? What's the right words for this? What are these turning points here? We talked about them yesterday. Minimums and maximums. What's the name for the minimums and maximums together? The fancy word that was also on your quiz? Extrema. So you're turning, there's 3 turning points, which means it's extrema, which are your max and mins, right? So they're the same thing, but turning points is used most of the time just kind of casually talking about it. I mean, you can see that on official things as well. All it is your max and mins, because that's where you're changing from increasing to decreasing or vice versa, right? So changing from increasing to decreasing, that's where our extrema are, or our turning points. Changing from concave up to concave down is where our points of inflection are, which is what this actually asks. Label the approximate location. So here, this is concave up till about right here, I would say, probably right where that number is. And then it becomes concave down, and then it changes again. I'd say probably right about there, because I sort of missed the green one. Green one's a little far off there, but somewhere right about there. Those look good, would you say? Okay. And then it says to, sorry, I'm looking for a different color here. It says to label, well, it says to highlight the concave up and concave down intervals. So when I went to put the highlighters on the table this morning, I realized I gave all of my highlighters to somebody, and I have none. So this is what you do when you only have your pencil and you're trying to denote things different ways. So I want to show concave up and concave down. So I can don't need it for that to be that thick. I can trace along here. I'm concave up till I get to here, right? And then I can scribble. Then I'm concave down, and then I'm concave up. So even if you just have one color, you can still show that they're different. Right? You can be creative in how you do that, but that's what we're looking for there. Okay. Any questions about that? And how many points of inflection do I have then? 2 points of inflection. And even though I can't write POI, I can do points as PTS. Like there's something, right? Take whatever you can get. You can write it out, the whole word out if you want. Okay, so let's look at this function down here. And shoot, I moved this thing. No, it's in my way. There we go. Maybe that'll work. All right, so here's my function. For the function y equals g of x, and it's labeled for me. That's good. I'm going to identify the characteristics. But before we do that, we're going to identify first positive and negative. And we're not going to write out sentences here, because here it's just really just asking us for the intervals of things. So the function is positive starting where? Negative infinity, and going to where? Negative 5. Right there till negative 5. Is it positive anywhere else? Yes, so I start back over where? At 2 and go to infinity. Very good. Everybody okay with that? Then it's negative starting where? Negative 5 and going to negative 2. Starting back over at negative 2 and going to 2. So this is negative, this is negative. Now, just for clarification purposes, because this happened on the 2 examples that we did for positive and negative, If this whole thing was stretched down some, like let's say my zeros stayed the same, but I just stretched it down some where this doesn't touch right here, then it would be okay. Like if this point wasn't at 0, if it was at -1 right here, then I could go from -5 all the way to 2, right? I just can't because it's touching the axis. Okay? We good on that? All right, I'll take that as a yes. So my domain of this function, what is it? All real numbers, which we write as -infinity to infinity. My range, what's the smallest y value we have? -8. And then I go to what? Infinity. I know I don't include my infinities. Do I include -8? Yes, -8 is a y value that is graphed on the function, therefore it is included. Okay, intervals where g of x increases. Where do I start increasing first? -4. Then I go to -2. Then I start increasing again at 1 and go to infinity with a question mark? Yes. We good? Okay, so I'm going to scroll so that you can see what I'm writing, which means you're going to have to look at your own graph. And I got to look at my paper. Intervals where g of x decreases. Where do I start decreasing first? -infinity. Good. And I go to -4. Do I decrease anywhere else? Yes. -2 to 1. All right, so relative minimum. I have a relative minimum at what? Oh, maximum. God, you know what? That was not even the first time I did that today. It's like I can't read. Relative maximum. I didn't need to erase that, though. Thank you. Relative maximum at x equals -2. Is that the only one? Yes. Okay, good. Relative minimum this time at x equals -4 and what? 1. Any questions on any of those? Stop me if you have a question because you don't know where we're getting some of this from. I'm going to assume we're just kind of rocking along here because it looks like we are. All right. Well, what's another word for relative? Local. So let's write local above this just so we remember. What's another word for absolute? Global. So let's write global above both of these. You won't have to write them both every time, but you know, just so that we keep them in our brains pretty good here. All right, so global maximum. None. Ooh. Okay, none. Oh, I can't write. None. Do we agree with that? None. Why? Because both ends go to infinity, right? And so because both ends go to infinity, you can tell me something about the degree of the polynomial. I do not want the actual number. Don't give me a number. But what can you tell me about the degree? What does it have to be? Even. Okay? Yeah, well, the exponent the degree has to be positive. You can't have a negative degree. But it's going to be even because if it's even, it ends up, which means we have to have we're not going to have a maximum, but we're guaranteed a minimum then, right? Got it. Okay. All right, so global minimum. What is, okay, global minimum is what? What is it? -8 at x equals 1. So remember, the maximums and minimums, what they are the y values, and then where they are the x values. Okay, we good on that? All right, great. Points of inflection. Well, let's go back up here and look at these together. I think, let's see, I have got concave up, and then I'm concave down. So I'd say probably right there. And then I'm concave down, then concave up. This one, I think it's kind of halfway right there. So I would say like at -3 and -1/2. And remember, we're estimating right now on an actual test, the points would probably be there. It would be asked in such a way you wouldn't feel like you're guessing. Okay? Because I know if you feel like you're guessing, you feel like you're just not going to get that right. But my points of inflection are at x equals -3 and -1/2. And that helps me with this part, right? The intervals where g of x is concave up, where does it start being concave up? Negative infinity. And we go till what? -3 till we hit that point of inflection, right? And then is it concave up anywhere else? Yes. Starts over being concave up at -1/2, and then we go to infinity. How many places is it concave down? 1. So we're just going to have one interval there, and it's actually the interval that fills that in right there. So we've got -3 to -1/2. Okay. What questions do you have? We good? So now you are good to go to finish that assignment that I gave you yesterday.